This building sways 6 feet in the wind. This bridge moves 27 feet side to side. And this dam holds back 9 trillion gallons of water. These structures should be impossible, but engineers found ways to make them work. Today, we're breaking down 5 engineering designs that shouldn't exist. Engineering is all about solving impossible problems. And some of these solutions sound absolutely insane until you understand the science behind them. Let's start with the tallest building in the world. The Burj Khalifa in Dubai stands 2,722 feet tall. That's over half a mile straight up into the sky. And at that height, wind is a serious problem. Up there, winds can reach 100 miles per hour. That much force would snap a rigid building like a twig. So how does the Burj Khalifa survive? The answer is genius. It sways. The top of the building can move up to 6 feet in any direction during high winds. Instead of fighting the wind, it dances with it. Inside, there's a massive tuned mass damper near the top. It's basically a giant pendulum that swings in the opposite direction of the wind, keeping the building stable. And the foundation? It goes 164 feet underground with over 200 concrete piles driven into the bedrock. The building is literally anchored into the earth. The Burj Khalifa doesn't fight nature, it works with it. That's why it's still standing. Next up, the Golden Gate Bridge in San Francisco. This bridge was considered impossible to build. The location had powerful ocean currents, constant fog, and winds up to 60 miles per hour. Plus, it sits on earthquake fault lines. But engineer Joseph Strauss had a plan, a suspension bridge. And this design is pure genius. See those massive cables. Each one contains 27,572 individual wires bundled together. That's enough wire to circle the Earth 3 times. These cables hang from towers that are 746 feet tall, and they support the entire roadway. Here's what makes it genius. The bridge is flexible. It doesn't fight the wind and earthquakes, it moves with them. The Golden Gate can sway up to 27 feet side to side in strong winds. The roadway can rise and fall 16 feet. This flexibility is exactly what keeps it from breaking. And that orange color? It's called International Orange. It was chosen because it's visible through San Francisco's famous fog, and it protects the steel from ocean salt corrosion. The bridge opened in 1937, and it's still standing strong almost 90 years later. Flexibility beats rigidity every time. Now let's talk about the Channel Tunnel, also called the Channel. It connects England and France under the English Channel. And this one is absolutely wild. The tunnel runs 31 miles long, with 23 miles of it underwater. That's longer than a marathon, all beneath the ocean floor. Here's the problem. How do you dig a tunnel under the ocean without water flooding in and drowning everyone? The answer? Tunnel boring machines. These massive machines are as long as 2 football fields and weigh 15,000 tons. They have rotating cutting heads with tungsten carbide teeth that grind through rock. But here's the genius part. As the machine digs forward, it immediately installs concrete tunnel lining behind it. The tunnel is being built and sealed at the same time. Water never gets a chance to flood in. They dug from both sides, England and France, meeting in the middle. And they had to be precise. If the calculations were off by even a few feet, the tunnels wouldn't connect. When they finally met in 1990, they were off by less than 2 inches horizontally and 2 inches vertically. After digging 23 miles underwater from opposite directions. That's insane precision. The Channel Tunnel opened in 1994 and has carried over 450 million passengers since then. All because engineers figured out how to build underwater without drowning. The Hoover Dam sits between Nevada and Arizona, holding back the entire Colorado River. And the pressure on this dam is absolutely insane. Lake Mead, the reservoir behind the dam, holds 9 trillion gallons of water. That's enough to cover the entire state of Pennsylvania in 1 foot of water. All that water creates massive pressure at the bottom of the dam. We're talking about 45,000 pounds per square foot trying to push through the concrete. So how does the dam not just crack and burst? The answer is in the shape. The dam isn't flat, it's curved. This arch shape redirects the water pressure into the canyon walls on both sides. The dam isn't holding all that weight by itself. The surrounding rock is doing most of the work. But here's the genius part. The dam is also incredibly thick at the base, 660 feet thick. That's 2 football fields of solid concrete. It gets thinner at the top where there's less pressure. And it's still standing strong almost 90 years later, holding back one of the biggest reservoirs in America. All because engineers understood that sometimes the best way to hold something back is to redirect the force, not fight it head-on. Finally, the Tokyo Skytree. It's the tallest tower in the world at 2,080 feet, and it's built in one of the most earthquake-prone places on Earth. Japan gets thousands of earthquakes every year. So how does this tower survive? The secret is inside. The tower has a massive central column that doesn't touch the outer structure. It's called a Shinbashira, inspired by ancient Japanese pagodas. When an earthquake hits, the outer tower sways one way and the inner column sways the opposite way. They counteract each other. It's like having a giant shock absorber built into the building. The tower also sits on a foundation with oil dampers and rubber cushions that absorb earthquake energy before it reaches the structure. In 2011, the Great East Japan earthquake hit, magnitude 9.0, one of the strongest earthquakes ever recorded. The Tokyo Skytree swayed, but it suffered zero structural damage. Over 400 million people have visited since it opened in 2012. And they're all standing in a tower that can survive the earth literally shaking beneath it. 5 engineering designs that should be impossible. But engineers don't accept impossible. They find solutions. The Burj Khalifa sways with the wind. The Golden Gate Bridge flexes instead of breaking. The Channel Tunnel was built underwater without flooding. The Hoover Dam redirects water pressure into canyon walls. And the Tokyo Skytree survives earthquakes with a hidden inner column. These aren't just structures, they're proof that humans can solve any problem with enough creativity and science. If you want more engineering breakdowns like this, hit subscribe. I post daily shorts about engineering facts, so check those out too. Thanks for watching.